what it can happen if we have not done our work properly, that's most important. So if you are in a company, definitely it will damage the business of your company, correct? Like in case of Maggie, Nestle has given a huge pricing for a mistake what they have done. If it is really a mistake, that's a different case. And secondarily, when you are coming back to your home, you have to think about your family, correct? So when you are in family, you have to think of your own parents or wife or children. So you have to think that for all those things, all those stuffs what the companies are doing, who are the sufferer? We all are the sufferer, correct? So for that reason, we need a real technique to understand what are the extra elements are present. That's nothing but the impurity profiling what we say. So if you look at the case of Maggie, what are the problems are there? Can you remember? One is lead content, correct? How to understand lead content? Means how they have understood. There are so many techniques which may Abid can tell you in a better way because that is an atomic spectroscopy techniques. PPMS, that's the technique which is used, which can exactly tell you in the ppm level where the lead presence is in your compound. In the same problem, what has happened with Ajinomoto, also with the Maggi, which is commonly known as? Tell the name of the compound. Monosodium glutamate. Correct? MSG we said. So how you identify the content of MSG? The only option to do HPLC. So liquid chromatography is a technique which can exactly separate MSG, and by the detection capability you can exactly quantify the amount of MSG present in the sample. So this is a very recent story what we are completely aware about that. But there are so many which we may forget or we don't know even. Like I can share another story which has happened in the year 1971. That's happened, it's known as a thalidomide story. Actually thalidomide, it's a drug molecule, okay? And you know about enantiomers? People are aware about enantiomers? Okay. So it's it's a mixture, it's a racemic mixture. That time there was no idea that it's possible to, also there is a chance of enantiomers. They don't know about that. They know it's a racemic mixture, means R and S mixture of that. So what has happened, they found out that thalidomide is a drug which actually works very nicely for headaches and mainly for the vomiting, and means to prevent nausea. And that time they started prescribing that drug to everyone. They have tested this drug on mouse, and what they found out, there is no dose which can harm, means which can cause a death of a mouse. So based on that, they have come that thalidomide at any dose is not at all harmful also to human being. And in Germany and Australia, they started prescribing this drug for the pregnant women because in the first 1 or 2 months to prevent the nausea. And what was the result after 1 year? And that result which has come out after 1 year, everyone was stunned because all the births, what has happened during that time, it was all having some limbs missing for the child. That time they found out, yes, this is a racemic mixture which is having R enantiomer, which is actually effect for that, means nausea, prevention of nausea, and S enantiomer, which actually works as a teratogenic effect, means and that's the reason that caused. And from there, from 1972 onwards, we understood, yes, HPLC is really important, and that's not only a simple reverse phase HPLC, also HPLC which can separate the chiral compounds, because separation of chiral compounds is altogether a different technique. It's the same HPLC, you need a different column. So when we'll talk about HPLC, the most important part is column. Anyway, at this moment I don't want to go inside that. Let's share some more stories in that. So that's the importance what we found out, means we all aware about why HPLC required. But again we'll see that HPLC is also having some limitations. Limitations in case of detection capability. Not HPLC, it means HPLC detectors having some limitations of detection level. Like I can say, you know about UV, correct? So same UV also will use with HPLC, and the detection capability will be hardly in the level of ppm. So we need also some detector which can go in the level of parts per trillion or parts per billion, even lower than that. Question is why? Can you remember almost 3 years back, we enjoyed lots of prawns in the market. I don't know how many non-vegetarians are there here, but the people who are really fond of non-veg, fond of also prawns. And just 3 years back, we enjoyed lots of prawns at much cheaper price. Hello? Yeah, the reason was, just come. So what is the reason? The reason was the whole consignment of India was not taken by US. So what they are done? They dumped in our market. And we are the people who doesn't means our FSI was not so active that time. So we don't know what we are eating. So actually what has happened that time, all the prawns were having an excessive amount of antibiotics which they don't want to take. Means in US they will be having a very stringent rules. So they don't want to take all those things. So they dumped in our market. Last but 1 year, means you have seen lots of Alfonso mangoes rejected by US for the same reason. It's having lots of pesticides which are banned in US. So they again dumped here at much less price. So earlier we have seen Alfonso mango 500 rupees per dozen. That time it was hardly 150 rupees per dozen. So that's the scenario. Now the question what comes, how I will understand these insecticides or these pesticides in my sample. So I need a real detection, means a detector which can detect in that level, and that's really a challenge. Please go to Agilent website. It's not for any marketing purpose, but if you are a member of there, you can download lots of literatures, lots of application notes which may be useful to you on HPLCs or whatever you're interested for, which Agilent makes. So those are all about the portfolio of Agilent. Let's come to now the main technical session. So please ask questions. It should be interactive. Now, what is the first is HPLC. Good news, I've just seen that professor has handed over a purchase order to us. So you're going to get HPLC. That's the good news for all of you. So what is HPLC? What is the full form of that? High performance? High pressure? Anything more? Also is known as high priced liquid chromatography. So it's not for all of us, but for managers obviously it's like that. So earlier it was really like that. It was means when the people was not aware about the real use of HPLC, we thought of like that. But slowly what has come out, even we are going to give a good amount for investing for HPLCs, but we have seen the ROI is very fast, means return of investment is really fast because it can give you a real output which you can get it by very soon. So what is HPLC? Not going to the presentation. HPLC is something we know is the high pressure liquid chromatography. So it's obviously based in liquid chromatography. So what others you can say is obviously on gas chromatography, correct? And in this portfolio of 1260, what you are going to get, we also have a chromatography that is known as SFC. Anybody heard about SFC? Supercritical fluid chromatography. Anyone knows about that? Okay, it's just for your knowledge. SFC is now going to be a new technique. Still is not so popular. It's not so popular because of other reasons. But SFC is a technique which I can say down the line after 10 years we have to think, because when I'm talking about HPLC, it's all about the solvents, correct? It's involved lots of organic solvents, and the people are day by day only talking about green chemistries. We are talking about green chemistry, green environment, and here we are using all the organic solvents, correct? So to avoid that, what has come is SFC, which is known as supercritical fluid chromatography. So instead of using water or these organic solvents, use carbon dioxide in supercritical form. And what I've seen is supercritical form carbon dioxide, which is actually very easy because only 31 degree centigrade temperature and 71 atmosphere pressure, carbon dioxide behaves as supercritical form. And what is the advantage of having a supercritical? Supercritical having all advantage of liquid and all advantage of gas. What is the challenge in case of HPLC is, I am not going to make all of you feared of HPLCs, it's not that, it's not a challenge at all, but is something challenge means when I need a very very fast run, which is not required here, then I have to run a very high flow rate, correct? But we know the solvents we are using, viscosities are more. So what happens? Back pressures are high. And that's the reason HPLCs, earlier it was HPLC, now it is UHPLC, because we realized 400 bar pressure is not enough. I have a column because now what has happened, column chemistries has developed a lot. You know about columns, correct? How it makes. In most of the cases, column is packed with silicas, correct? But the chromatography, when you do like a gravitational chromatography, the particle size was too big. It was more than 100 micron particle size. When it comes down to flash chromatography, I don't know, you have flash here? Okay, so if you are thinking of flash chromatography, the particle size comes down to 35 microns. And when we are talking of HPLCs, it starts from 5 micron, 3.5 micron, now 1.8 micron, probably even less in coming days. So is already reached in the level of sub 2 micron. We say that the sub 2 micron, not 1.8 micron, because it's not possible to make all the particle size 1.8 micron. Is in between 1.6 to 2, plus minus 0.2% variation is always there for across the vendors. So all we say is a sub 2 micron particle size. And when we are reducing the particle size, what will happen? There is a huge surface area is increasing. That means more interactions with your liquid, means with your mobile phase. And that means a huge back pressure generates. And for that reason, when column chemistries has really improved a lot, we have to think an instrument of HPLCs which can work at a very high pressure. So 400 bar system is still on and is going very nicely with pharma, because they used to go with all the methods which has developed maybe in 1970s, 80s by some guy, and we cannot change it easily because this was developed by USP and all pharmacopoeias, which is not easy to change. But in other cases, day by day, this UHPLCs is now being very popular. What is the difference? Now it is ultra high performance. So earlier it is 400 bar. The instrument you are going to buy, it is a 600 bar instrument. Correct, Vinay? Is a 600 bar? It's a 600 bar instrument. And we also have another system that can reach 1200 bar. And now in last year we have also come with another system with 1300 bar. And why? It is just to run the fast run. I have no time to wait. Again, it's not for academics. 600 bar is more than enough for academics. But the people in industries, like most of the cases in bioanalytical, bioequivalence, and some pharma R&D companies, which is having no time because I have to scan maximum number of compounds at minimum time, because there is a huge competition among all the pharma companies for developing the methods. If you go to a pharma companies, you can see that there is a known as a 96 oil plate. Maybe you all are aware about that. And then we are scanning is known as a combinatorial chemistry. They are scanning all molecules in different groups at very fast time. So for that reason, you need a very fast scan. And so for that reason, they need a really high pressure systems. Now in case of HPLC, there are two types. One is known as a quaternary type of system. Another one is known as binary systems. What you are going to purchase is a quaternary system. Quaternary doesn't mean it has 4 pumps. Don't feel quaternary means it has 4 pumps. No. This name has come from how many solvents you can handle together. So when I am saying is a quaternary, means you can handle 4 solvents together. If it is binary, you can handle 2 solvents together. And it's quite unlikely for you to know that in case of quaternary system, you have one pump. For binary system, you have two pumps. Why? Because the quaternary systems are known as a low pressure gradient system, which actually mix the solvents first, then it delivers. In case of pharma, if you go to pharma companies, 90% are with quaternary systems. Why? Because there are certain advantage of having a quaternary systems. Obviously, you can use the four solvents together. That's a real advantage. But who is going to use four solvents together? But it's something like lethargy. Today we are having water acetonitrile. I can also keep a methanol there. I can also keep another solvent there in that for washing. So all solvents will be there. Whichever I want, I can use it immediately. Correct? So sometimes it's used, and we have some methods also with the ternary that is different. So, but that's the reason quaternary is extremely popular in case of pharma as well. So you are going to get quaternary. Next is, I don't want to go in this all. We also have different systems like GPC, that is known as gel permeation chromatography, or also is known as size exclusion chromatography. So in that case, it works on the size of the molecule. It's like, if it is a smaller size, it has to go more number of pores. So it takes more time for the smaller size molecule to go at the end of the column. Higher molecular weight, and the last peak will be the lowest molecular weight. And it calculates the molecular distribution among all those. But please don't think that GPC can work like a mass spec. It's not. It's a molecular weight distribution, not the mass, which can measure out of that. So these products are made in Germany for Agilent. And just see how this method works. So I will just go through this. So this is a chromatogram. You know about chromatogram? So this is the chromatogram, and chromatogram is mainly based on time and the absorbance unit. So what is absorbance unit? Means there should be a detector. So what are the main HPLC components? The first is pump. What I already said is a pump. Now this pump can be, it's not so clear, I think it goes this side, but yes, here you can see. So these pumps, for you it's a quaternary pump, can deliver up to 10 ml per minute if you wish. But don't try with a 4.6 mm ID column with a 10 ml per minute flow rate. It will not. So what is the, you can say, the benefit of having a quaternary system? You can also do some preparative work in that system. Like the normal column which we used to use is a 4.6 mm with the normal detectors of HPLC. But you also will be having option to buy one 10 mm ID column and can do some preparative work, because you can go up to 10 ml per minute flow rate by this column. So preparative, you know what is preparative? Preparative means there are two types of, again, one is analytical type, another one is preparative chromatography. Analytical means your goal is to separate the compounds, but not to collect, just to see what is the amount of compounds are present. You are separating and you are just finding out the area out of that. But for preparative, when you are collecting that, so here, suppose you are doing a natural products, or you are working in biologics, maybe some critical compounds, complex mixture, you want to take a fraction out of that to see what exactly that one is. That is possible in the low scale by this system. So that's a real advantage to have this system of 10 ml per minute flow rate. So this is an example of ternary. I don't want. This is another one. That's a solvent blending capability. Again, not with this system, but we have the systems where you can do the solvent blending automatically. It's something like when we are doing the method development, we need sometimes different buffers, correct? Buffers are required. And we don't know at which concentration of buffer your method is going to develop. So maybe you have started with 1 molar buffer and you have seen the separation has not happened. I need a further dilution of 0.1. So what you have to do, you have to go back again to the wet lab and again dilute it, coming back, and definitely somebody will talk in between, you will do some mistakes, possibilities there. So there is a chance of error, and also there is a chance of obviously the mistakes, and as well as there is a chance that you have to work again to go back, so some lethargy works in between, correct? So instead of that, this software, what it does, you tells the software, I am using 1 molar, next injection I want 0.1 molar, next injection give it 0.01. This instrument can automatically dilute, not instrument, actually software, automatically dilute and deliver it. So that's a real advantage to have a solvent blending facility. You're also going to get an auto sampler. Auto sampler is there, Vinay, correct? Auto sampler is there? Okay. So you're also going to get an auto sampler. Auto sampler means you can just going to place your sample there. So no need to inject for your side. It's just plug and play. You just say, okay, 10 microliter inject from this number of vial. It will be done. So no need of again to wash the syringe and all those problems. So everything is automatic, and it will be capable of taking 96 vials together. So you can keep 96 vials there. Not to think that 96 vials will inject at a time, but you can keep 96 vials and it will be injected sequentially. Next is, what is more important is the detection. Now, first of all, I have a pump, so that's actually help to pump my mobile phase. I have an auto sampler which introduce my sample inside that, and then we have a column. Column is the heart of the whole thing, because column is a part which actually separates, correct? And based on the columns, you separates totally, the separation depends on the column. So anyway, don't be scared of column. It's simply C18 which works most of the time, and will give a C18 with your system anyway. And then finally, I need a detector to detect. And there are so many detectors of HPLC. Can anyone name some of the detectors? Sorry? Thermal detector. No, not for HPLC. HPLC detectors. ECD? ECD, you are right, but I don't know in what sense you have said ECD, because ECD is common for GC as well as LC. The full forms are different. What is the full form you want to say? So one is ECD is electron capture detector, which is meant for GC, which is having a nickel 63 radioisotope inside that, and which bombards those gamma there, beta rays there. That's the difference. And ECD in HPLC is the most critical detector. So C started with the most critical detector, that is known as electrochemical detector. And electrochemical detection is having a very special applications like the neurotransmitters. In case of neurotransmitters, the only option is to have an ECD. Except that the most common, please talk about the most common detectors of HPLC. UV. The first is UV. The second, RI, refractive index. We all know about that. So UV and RI, these two are the most common, and then fluorescence detectors. The compounds which are fluorescence active can detect very nicely with the fluorescence light. Next. PDA, anybody said? Okay. So PDA, yes, that's PDA or DAD, these two are the same. One vendor says is PDA, we say as a DAD. Is a photodiode array or diode array detector, things remain same. It's actually based on UV, but there is a grating. So I will explain PDA in more details. So what else? Plasma? Okay. So another detector is ELSD. It's known as evaporative light scattering detector. And for what these will be used, I will explain you. The first of all, most important is UV. So the compounds which are having pi-pi star transitions, or you can say a chromophore, UV chromophore, like a benzene ring having an UV chromophore, it will be detected by UV. Correct? But again, based on these pi-pi star transitions, the UV pattern of each of the compounds are different. Like someone will be having a maximum absorbance at 230 nanometer. Someone will be having a maximum absorbance at 280 nanometer. So when I am doing UV, I have to know that what is the UV max for that compound. Correct? Is it UV or DAD here? Okay. So now you realize the difference. In case of UV, so it will be extremely useful if it is known. So for pharma industries, because the compounds are known, they want UV. Why? Because UV is very, very specific. So you know this compound 254, set 254 wavelength, and that will be extremely sensitive because it is only monitoring only one wavelength, correct? Now next step is, but for us, when I am working in academics or in any research, I don't know much about my molecule, correct? So I don't know what will be the UV max for my molecule. And even in case of, I think in biology's matrix as well, there are a mixture of compounds. So someone will be having a max of 300, someone will be having 200, someone will be having 250. How to take that wavelength? That's a challenge. So for that reason, DAD comes, diode array detector. What it does? Every point will be scanned from 190 to 600 nanometer. So every point of your peak will be scanned by DAD, and it will tell you this is the UV max for this compound. So it is an ideal for unknown molecule analysis or for any types of research work based on UV. Correct? So again, DAD can work. Obviously there are some disadvantages for DAD or UV based. What are the disadvantages? It can only detect if it is having a chromophore, UV chromophore. Correct? It cannot detect if I add some sand inside your compound. Can it detect? No. Can it be possible to know the sand is present or something else is present in my compound by UV if it is not UV active? Identification is not possible, but by quantitation we can say something else is there. Because when we are doing quantitation by UV, I know my compound is 254. You set the wavelength, you have the standard to run, you are running standard, so you are making a calibration curve, then you are running this test sample and it will tell you this is the amount of compound present there, so rest of the things are something different. So it's also possible. But you are not able to detect some unknowns which is there, which is not having any UV activity.